All over the world, wooden skyscrapers are rising from the ground, pioneered by visionary builders. Thanks to cutting-edge technologies, what seemed impossible just a few years ago is now a reality. This marks the beginning of a global race to redefine urban construction. By combining wood with concrete, entire residential complexes are being built using a renewable resource that constantly regenerates. Easier to assemble, it's revolutionizing the way we construct buildings. At 85.4 meters, the world's tallest wooden building is currently located in Brumunddal, Norway.
I think this is only a beginning of high-rise timber buildings.
Constructed using glulam, layers of wood slats glued together to form massive beams and supports. This innovative material enables the construction of record-breaking buildings, like in Milwaukee in the US, where the tallest hybrid timber skyscraper was built. A high-end skyscraper combining concrete and wood.
The customers don't need to be sold. They come in here, they see the beauty of the built environment, and it sells itself.
The Dutch city of Eindhoven is raising the bar even further with a groundbreaking wooden structure set to surpass anything built before.
The skill, of course, is a once-in-a-lifetime project, absolutely.
A race of superlatives has begun. Who will reach new heights in building with wood? The Dutch city of Eindhoven. Its 250,000 inhabitants could soon have a new landmark: the Dutch mountains. Consisting of two conjoined towers, it will become the largest wooden building in the world. Two towers, 100 and 130 meters tall, connected by a valley-shaped wooden structure, visible from anywhere in Eindhoven. That's the ambitious plan. Architect Marco Vermeulen is the creative mind behind the visionary project. His ambition? To redefine the future of construction.
The future Dutch mountains, as you can see, a beautiful parking place at this moment. But it has some very important landscape elements. For instance, over there is the Dommel, a small river. But it connects the northern part of the city to the center. And you can see this location. I mean, it feels very peripheral, but it connects the campus site of the University of Technology to the city center of Eindhoven. So it's a very interesting pivotal point in the city. So it has a lot of potential. Of course, it doesn't show yet, but in a few years, from here on, the Dutch mountains will emerge.
Of course, the prospect of breaking a world record is an important motivation for him. But the Dutch mountains won't be a purely wooden structure. The 38-story building is being erected using a timber hybrid construction method. A reinforced concrete core housing the elevators will be encased in a gigantic timber framework. The plans for the city's new landmark were drawn up in this office. Marco Vermeulen has been working on his vision since 2019. What began as a bold idea years ago is now taking shape, though virtually for the time being. Vermeulen plans to use 9,500 cubic meters of wood, making up for 2/3 of the entire building material.
We enter now the building here, and this is the core, the winter garden of the building. And obviously it's very green, but it's also very important as a central space in the building, and it connects all the functions. So from here on, you can directly go to the hotel reception, you can enter the offices, and also there is a corridor towards the houses. It's like at the heart of the building, and from there on, it kind of evolves in these two towers.
But there are also drawbacks to building with wood. The preparation work must be extremely precise. Nothing can be adjusted later on site. The hardest part of building a timber high-rise is not the construction, but the planning.
So the Dutch mountains consist out of two towers. This one is 130 meters high. That one is 100 meters high. And you can see this kind of fluid shape which connects the two towers. And what's also very important is that the core of the two towers, that is made out of concrete, but all the rest is made out of wood. So in that sense, it's not a full timber tower, it's a hybrid tower. We use the concrete where we need to use the concrete, and where we can use wood, we do use wood.
The winter garden of the Dutch mountains will be open to all visitors. But the exposed wood throughout the structure is more than just an aesthetic feature. It serves a greater purpose.
One big advantage of building with wood is that it contains CO2. So when a tree grows, of course, it absorbs CO2 and turns it into wood. And by using this wood as a building material, the CO2 will not be released again. If you build with wood, you can use buildings as a carbon sink.
And that could help shrink our planet's carbon footprint. However, the wood used here won't be in its raw, untreated form.
So a large part of the building will be constructed with cross-laminated timber, like big multiplex, engineered wood, which gives the building strength also. It consists out of planks, cross-laminated into big boards, up to 18 meters long, 4 meters wide. It is as strong as concrete, but much lighter.
Change of location, Norway. Visions and records are already a reality here. In Brumunddal, 100 kilometers north of Oslo, Mjøstårnet stands on Lake Mjøsa. The tower rises 86 meters above the lake. Its extraordinary design is particularly impressive at the very top. A record-setting building. Never before has a wooden structure reached this height.
So this is a simplifying way of explaining how the building is made. We see the diagonal thrusters here, kind of gives this building its strength, keeps it in place from both the wind and the ground movement.
Timber buildings are lighter than their concrete counterparts, making them more vulnerable to wind forces. The construction of the giant began in 2018, using 3,500 cubic meters of wood, the equivalent of around 14,000 trees. When it opened in March 2019, it set a record. At 85.4 meters, Mjøstårnet would be the tallest all-timber building in the world. The record attempt almost failed. The team discovered a competing project in Vienna reaching 84 meters. In a bold move, they quickly decided to aim higher, literally, by increasing the height of their building.
We came up with a solution that we could raise the upper construction even 5 meters more than we already had, but we had to sand off all the corners for the columns, make them rounded off so the wind wouldn't catch them. And our building height was raised 5 meters to 85.4, and then again we became the tallest building in the world.
The mission here is all about wood. Alongside the hotel, an office building and a public swimming pool have been constructed. 3 apartment buildings stand by the lake in front of the tower, each one built entirely from timber. The multifunctional tower houses a restaurant, offices, and conference rooms, along with apartments and a 72-room hotel. The tower has a total area of 11,300 square meters. With the Mjøstårnet, Norwegian private investor Arthur Burkhardt has fulfilled a lifelong dream.
My vision was to show what is possible using wood in a small place for office part, hotel part, and apartments. And this is the result.
The result could potentially inspire urban planners around the globe.
But the most important thing for us is that this building is supposed to inspire others to do the same thing, because we believe that if we are supposed to reach a more sustainable built future, we have to think using more sustainable materials. Mjøstårnet has proved that it is possible to build large, complex buildings with wood.
The Norwegian name Mjøstårnet means the Tower of Lake Mjøsa. You can even see it from far away. At first glance, the wooden hotel doesn't look unusual at all. You enter the building through a revolving door.
And this is the entrance for all the people working here, living here, and visiting here. So this is kind of the main hub, where everybody meets.
From the moment you step into the entrance area, it's clear you're surrounded by wood. The scent is unmistakable, wafting through the air within just a few meters. Beyond the entrance lies the hotel lobby, with the restaurant and breakfast area just behind it. The ground floor overlooking the lake is encased in glass. The building's beams and supports are on full display, and that's no accident. It's part of the design.
Well, when you're working with wood and the end result is kind of almost as an interior finish, so you don't need to kind of hide it because it becomes the interior itself. And when you look at the timber columns here, you want to touch them, you want to see it, you want to smell them because it gives the atmosphere to the room. It's totally different from a traditional steel and concrete building.
The wooden staircase leads from the restaurant to the meeting and conference rooms above. Just like the building, the staircase is custom-made from solid wood. Unlike the rest, however, it's not made of pine and spruce, but of oak.
In this common area, you kind of wanted a jewel for the building that really expose what wood can do. And since we have the meeting facilities upstairs and we wanted to connect them with the restaurant, what better way of doing that with a nice staircase where you can really feel the kind of the organic part of the woods.
The stairs lead to the conference area. All conference rooms at the Wood Hotel in Brumunddal are designed to host meetings, cater events, and accommodate exhibitions. Not necessarily for large corporations. The adaptable rooms are mainly designed for private groups, for the people who live here and see the tower every day.
This is kind of like general meeting facilities, but as you can see, we can close off those two parts, so you can have a small meeting here and a small meeting there, or for example, a large wedding dinner when you can put up long tables all the way and have the restaurant serve you up here. So it's very flexible and it meets the needs for the people of Brumunddal.
The space is followed by 5 office floors, topped by the 4 hotel floors, which house 72 rooms. The apartments are situated on floors 12 to 16. The viewing terrace and a penthouse cap the building on the 18th floor. On the public terrace, strong winds can make for a turbulent experience.
And now we're standing on the tallest part of the viewing platform, and we have a nice view of Lake Mjøsa, Norway's largest lake. And we can actually see where the timber comes from in a way, because all this area here is known for the forestry and wood processing industry.
After all, Norway is known for its abundance of wood. The material has been used to build houses here for centuries. Today, the demand is greater than ever before. Vermeulen is one of the companies specializing in the processing of glulam, glued laminated timber. The company is located just 15 kilometers from the world's largest all-timber high-rise. Each day, up to 10 trucks deliver timber from the surrounding sawmills. This wood is used to produce glulam, a construction material that has proven its reliability in the building of high-rise timber structures. But not every board is suitable. The pre-selection of material is critical to the following production steps.
There is a quite big natural variance in the material, but they are strength graded and sorted so that all the ones that we see here, they have the same similar strength. Strength grading means that every individual board needs to go through a machine that presses the board down to find out how flexible and strong it is.
These boards will ultimately be turned into beams, which have to support an entire high-rise. First, the pallets are unloaded and pre-sorted. Once all the boards of similar strength are grouped together, the countless pieces begin to form a beam. Each individual board is checked again for moisture. 10 boards are then clamped together in a milling and gluing machine. In the first step, the ends are milled to a depth of approximately 1 centimeter before the milled area is filled with adhesive. One board is now pushed onto the other and glued together to create a virtually endless workpiece. In theory, beams more than 30 meters long can be created.
Well, the boards, they have fingers in their ends. They're pressed together and we make an endlessly long plank, which we then cut into the desired length that the final beam is going to have.
Even before the glue lam is processed, it must be clear what length and thickness the resulting beam should have. This is the only way to turn the long, thin boards into snug-fitting beams. Boards are glued to one another until a solid component results, the stuff that all timber high-rises are made of. To ensure that the two-component adhesive sets properly, one has to wait. It takes time. A heating kiln saves time by exerting pressure on the wood.
Inside this room, all the glue lam planks are pressed together, very high pressure, both vertically and horizontally. So then they stay there for about 1 hour, and when we take them out, the glue has hardened and they are glue lam beams.
What comes out looks like a single huge board, but there are still 8 individual parts. Not all the boards have been glued together, but they were all put through the pressing and drying process together. Before the boards that have been glued together can be joined to other identical boards, their surface is thoroughly processed from all sides to ensure that everything fits perfectly. Each part must be identical down to the millimeter. This is the only way to ensure that the glue lam becomes one, a component without air pockets.
We take the beams out of the press, we plane them and smooth them so that they are ready for the building place or for the customer.
The factory also does all the preparation work on the beam. Here, holes for heating pipes and metal connectors are pre-drilled.
Precision that we obtain with this machinery is quite extreme. It's less than 1 millimeter accuracy, so it's super precise, and then we can prefabricate in the factory and just install at the building site like Lego.
This is because the beams are bolted together with simple metal plates.
What we see here is what is going to be a connector or a connecting part of the glue lam beam. where the thickness of the steel plate comes and fills here. And all these holes are for dowels and bolts that are going to connect the steel and the timber together.
The 18 planks now have been turned into a solid beam. The record-breaking construction in Brumunddal, 15 kilometers away, was also completed with girders like these.
We need very big dimensions for the world's tallest timber building. So what we do is that we glue the beams together into a large glulam block, glulam cake, if you like. So there is glue along the sides here, and we press them together with a heavy weight so that they become one large section. After we have done that gluing, we need to plane them so that they look nice and smooth again.
The beams are then inserted into each other and bolted together on site using these connectors. There are virtually no leftovers in production. Everything is recycled here. What is left over is sold. Mjøstårnet opens its doors every Thursday.
Plates, we call them hobby plates, that private people can come and buy every week for a very good price. So this is very, very popular, and it's also helping our company and the society of becoming more sustainable.
And so, the hunt for records also has a sustainable side effect. As a renewable raw material, can wood be the solution to lots of our problems? Trees store carbon as they grow, so wooden buildings are nothing other than vast carbon reservoirs.
Well, the trend is quite clear, I would say, that more and more focus is on the sustainability, meaning that if you can build by storing carbon and having less energy consumption, well, then you can build in a better way for the future.
Wood is and remains the measure of all things here in Norway. Hybrids with concrete. That would never have been an option for investor Otto Buchat.
This is 100% building in timber. What they do other places, I don't know, but it's important that it's 100% timber, or then it's not real.
Change of location, the US. Milwaukee on Lake Michigan in the state of Wisconsin. Here too, people think big. In the 19th century, the city's development was shaped by the influx of German immigrants. Of course, at the time, they could only dream of a 25-story timber high-rise. Today, downtown Milwaukee is home to the largest timber hybrid high-rise in the world, the Ascent.
Ascent is a 259-unit apartment building. There's also retail on the ground floor. The parking garage sits above the ground floor. And then on top of the parking structure, we have a swimming pool and a fitness center. And then the entire roof, the entire top floor, is an amenity floor. So it's not just a mass timber building. It is also one of the most sophisticated and amenitized buildings in the country.
19 stories of timber construction sit on 6 stories of concrete, which serve as a parking garage for the residents. Strictly speaking, the Ascent is not a purely timber high-rise, and concrete was also used in the construction of the elevator shafts. Nevertheless, they're proud of the wood and concrete hybrid. At 87 meters when it opened, it was a meter taller than the Mjøstårnet in Norway, as the tallest timber hybrid high-rise, to be precise.
The project started in March of 2018. The path to approval started then, and the first meeting with the public officials at the city of Milwaukee was in the first week of May of 2018. And we showed them a possible path to have a tall timber building approved. And the way we like to say it, they didn't say no. And we just kept going until someone was going to say no, and no one ever did.
The Giant is home to 259 luxury apartments of various sizes. Timber hybrid construction combines timber, concrete, and steel with their respective strengths. Visible elements are primarily made of wood. The foundations, floors, and elevator shafts are made of reinforced concrete. The beams are visible throughout the building. These are made of American white spruce. For all its sustainability, the structure does not skimp on luxury. A commons area on the top floor is open to all residents. From here, you can enjoy the panorama or have a rooftop party.
This is one of our 2 clubhouses. So we actually built 2 of them, one on the south side, one on the north side. And we really, in addition to creating an incredible built environment, we also wanted to create incomparable amenities. And that's why we built 2 of them. So this one can never be reserved for a private party. This is always open to the residents.
The designers even kept the cold winter days in mind. Residents can work on their swing in any weather.
Wisconsin, of course, has similar climate to Germany, and so in the wintertime, you can't play golf outside, and we provide this wonderful amenity that gets a lot of use when it's cold outside.
Residents can reserve the second clubhouse with a show kitchen and host up to 100 guests here. Everyone can use the barbecue and enjoy great movies on the huge screen. Sheltered from the wind, of course.
You can see we have extra tall glass around the perimeter. It's not required by code. We were thinking about the wind because we were so high up, and so we wanted to make sure that people would be comfortable on the rooftop here. And we have this 9-screen assembly here. It's a really, really incredible space for the residents.
A structure that creates attractions, which is why the creators chose wood as the construction material.
We're not doing this because it's sustainable. We're doing this because it's a better way to build. It's fast, and it's beautiful, and it's precise, and it's light, and yes, it's also way more sustainable. And that's the order that we think about it in.
There was little time to think in Altheim in Austria. The Ascent was practically built here. All of the glulam elements were manufactured here, awarding them the contract for the record-breaking building. A genuine adventure for the Austrians.
We received the request at a very exciting time. It was just after the outbreak of COVID, so we couldn't even travel to the States to negotiate with the client. We talked through all the details in 4 or 5 video conferences, and then we were awarded the contract and started our work.
Wood arrives at the plant by truck every day. Forestry legislation in Central Europe is strict. New growth must exceed the wood harvested. This timber delivery still has a long way to go.
It's not dry yet. It's still wet, a little bit damp. And to produce a glulam beam later, we have to dry the wood so that the strength is right. So we can't glue wet wood together.
Here in Austria, all of the boards delivered are checked individually. The first check is performed manually.
We have 4 different sorting stations here. The employee who sorts the wood pulls the wood into the right position from which it will later drop into the right box.
Boards with too many large knots are rejected. This ensures that all of the parts joined together later on will have a similar load-bearing capacity. However, before the boards are glued together, they have to dry. To guarantee this, timber is inserted between each layer of boards.
Air can pass through and take the moisture with it, to keep the board from becoming moldy or discolored.
The boards are then temporarily stored in stacks such as these. Either they're waiting to be processed on the company grounds, or they're sent directly into one of the 4 drying kilns.
These are fresh air exhaust air drying kilns. Fresh air enters and absorbs the moisture from the wood, and the humid air is sent outside.
The boards are dried for 5 days at 70 degrees Celsius, creating maximum residual moisture of 12%. Only then can they be processed. The dry timber is then loaded individually into the first machine. It checks the levels of moisture still in the wood and the load-bearing capacity once again in a single work step. Board by board is also measured with a laser to rule out even the slightest curvature. But this is far from the final test. It's off to the X-ray machine where every single board is X-rayed, photo included.
It works like in a hospital. If I break my hand, my arm is X-rayed. And we don't do anything different here. We X-ray every board, and then we see this here on the screen. Where's the core? Where are the branches? And based on this diagram, the wood is then sorted by strength.
Once the test has been passed, processing can begin. 11 boards are fed into a milling machine. The principle is the same almost everywhere in the world. The ends of the boards are milled, and then glue and hardener are applied to the grooves.
We have a 2-component adhesive here, one glue and one hardener. And when these two come together, they react with one another and it hardens.
The individual boards are joined lengthwise to create slats that are essentially endless in length. The slats are always exactly the same length as the beam they will later be used to create. This ensures that everything will match up and form one single piece. The next step is to apply the adhesive on each slat and always lengthwise. The slats are then folded together to create a larger composite. Here too, the adhesive must harden under pressure. As the adhesive residues along the sides show, the long slats have now become a small beam. But before the wooden components can be glued together with others, they have to be processed from all sides. Glue residue and uneven spots are sanded away. And the beams still aren't completely ready to be sent out into the world. There are still more tests to come. Each beam is drilled to remove a control plug like this one. The resulting borehole is immediately resealed with a repair plug. The sample is sent to the lab, one from every component they produce here.
These are the samples, or plugs, and here's the adhesive bond. You can see it better here. We've marked the adhesive with a pen so we can clamp it and shear it off right where the adhesive bond is. And then we test it.
The force it takes to loosen the adhesive bonding is tested and measured. Snap. The beams cannot be processed further until they pass this test. The visual finish is applied in what is known as the sanding hall.
This is how the wooden components come to us before they're finished. They're plain smooth. But we're limited in width here. We can produce a maximum of 26 centimeters in width or height. And if we need wider or taller components for high-rise buildings, we still have to glue them together by hand. In other words, glue is applied with a trowel, and then the components are stacked on top of each other and pressed together again. And this is how the components look when they're finished. So here we've glued two components together again with a block joint.
Precision is the top priority everywhere. The beams will require no further work when they reach the construction sites, as this CNC milling machine is already used in the final work step here in the plant. The beams are provided with the exact holes and cuts that will be needed to channel wiring and ducts later on. The CNC milling machine works with millimeter precision. It has to, because the components should have all the necessary holes for bolts and dowels when they leave the plant.
We arrive at the construction site with prefabricated components, with the connectors already attached. There, the components are assembled, much like a building block system.
Wie ein Baukastensystem mehr oder weniger zusammengesetzt.
This also means that each carrier beam is unique and can only be installed where it was designed to go. That's the only place it will fit. Steel connectors join the beams and columns together.
On the construction site, it's inserted here with a crane. It's lifted and then it's done. We don't need a cordless screwdriver or a drill or a circular saw. It's all ready to go, pre-assembled in the production hall beforehand and then just assembled on the construction site.
High-rise timber buildings may still be flagship projects, but the industry has been waiting in the wings for a long time.
Timber construction in urban areas is just getting started. 10 years from now, you're going to see timber high-rises in cities where there hasn't been a single timber building to date, or at least no timber high-rise.
There's already a building in the US that was built with wood from Austria. Standing 87 meters tall, the Ascent is the tallest wooden skyscraper in the world.
The size of Ascent, which uses over 2 million lineal board feet of timber, really made most North American manufacturers incapable of delivering that volume.
The Ascent is a hybrid of wood and concrete. The bottom 6 floors, parts of the 7th floor, and the 2 elevator shafts were made of reinforced concrete. The rest is made of wood, and the tenants like that. But the Ascent is not a place for alternative living. It's still a luxury apartment building for exclusive customers.
So we're standing here in our lobby. This is a great space for residents to come in, connect with our concierge team. Additionally, our mailboxes are here.
It's impossible to imagine luxury buildings in major US cities without a concierge. The reasons for this are as varied as the tasks of a concierge.
They're here to accept deliveries. They're here to check in guests. Maybe someone has a cleaning service that they will let upstairs. So they're just a doorman that offers more services.
And this is, of course, already included in the apartment rent. These are up to 250 square meters in size, and only a few are currently available, like this 3-room apartment.
This is 1999 square feet. This apartment would rent for generally between about $8,000 and $9,000 per month.
With the view included. Once inside, you quickly forget that this is a timber high-rise. From the outside and inside, at first glance, the Ascent looks like any other modern building.
this also translates to an app on your phone. So from your phone, anywhere in the world, you can control your lights and your locks in your apartment. So if you have a guest over, or if you have a dog walker, or a nanny, or a cleaner, you can unlock your door remotely, which is really nice. And then here, this is for in-floor heat, just a really nice, cozy feature, again, bringing in that warmth to the building.
And of course, a luxury building needs a swimming pool. But only the sauna is made of wood here. Unlike in Europe, it's always heated during the day, even when it's not in use.
When it's cold here in Milwaukee, the floors are heated and it's just so warm and toasty in here. The pool is also heated, so that's just really such a great space that residents can enjoy 24/7, 365.
The uppermost of 6 parking levels is located directly below the pool. The outline of the pool is clearly visible from here. Also clearly visible, the 2 reinforced concrete elevator shafts.
This is the concrete core. So you can see both cores. We have a stair and elevator core here on the south of the building, and then a stair core on the north side. And so both of these core walls are what we call the lateral system for the structure. So they hold it up against wind loads, or if there was an earthquake, that's what holds that up. And these cores actually run up the whole height of the structure all the way to the top.
The 19-story timber structure begins above the parking deck. These are by far the largest wooden columns that have been installed in the building.
So this is the fitness center of the building. It's actually the first floor of the mass timber. So the reason it's the biggest is you can imagine the taller up the height, it's holding up more floors. So this column is holding up 19 floors of mass timber. So obviously all the columns at the base are usually the largest.
To support 19 stories, the huge components could have been somewhat smaller. But since wood is a combustible material, the outermost part of the beam also has a fire protection function.
So the interesting thing is you look at this column and it's fairly big, right? But if you can imagine structurally when we designed it, the outside 4.5 inches all around, we pretend effectively that it's not there. The inside of this column has to be able to stand up with the entire outside being burned.
How long will the Ascent's height record last? Probably not long, because the construction of timber skyscrapers is booming all over the world. And as everyone knows, just another meter more, and the title is gone. That's exactly how the Ascent became the record holder.
None of us did actually ever intend to try to break a record, but when we went to 25 stories, we suddenly realized that we were within about a meter of the Mjøstårnet tower in Norway. And so by just making our retail ground floor a little taller, we start to chip away at it. And then the final sort of design move that when we said, well, we're so close, why not? We just said, take the roof and do this. And that's why this roof is tilted up, and that's how we crossed the threshold.
The hunt for records is often tricky. In the end, it's not just the title that counts, but also speed.
The final piece of timber on the 25th floor roof was installed in December of 2021, and the first people moved into the building in July of 2022. They moved in 22 months after groundbreaking, and we estimate that's 3 to 4 months in accelerated schedule over a concrete building.
And so, the Ascent in Milwaukee became the tallest timber high-rise in the world as a hybrid construction. How long this record will last? Uncertain. Property developers all over the world are motivated. For timber high-rise construction, the best is yet to come.
Is it new? Yes, it's newer. Does the supply chain have to be built out? Yes, the supply chain has to be built out. Insurance problems have to be solved. Skill gaps need to be overcome. But those are a matter of time. All of those problems, steel-faced, concrete-faced, they took their decades, they figured it out.
Back in Eindhoven, great things are yet to come here. The next record breaker is already waiting in the wings. Architect Marco Vermeulen has been planning the Dutch mountains since 2019. A building consisting of 2 interconnected towers. Taller than any other timber skyscraper in the world, That would make the world record building a Dutch one.
If you look at the word Holland, it also derives from Holsland. So in a way, there is a kind of logic way of building much more in wood in the Netherlands. Of course, we used to be a wood constructing country also, mainly ships, but we kind of lost this way of building with wood.
Where a parking lot still stands today, 2 towers will soon rise into the Dutch sky, 130 and 100 meters tall. Beside the banks of the Dommel, a tributary of the Meuse, up to 6,000 new apartments will be built alongside offices.
This is on the eastern part of a large development area, and this whole area will be transformed in the coming years. And the site of the Dutch mountains is one of the first sites to be developed. A complete new city is being built within the city of Eindhoven.
The 38-story high-rise is being built using a timber hybrid construction method. It's too large for a purely timber construction.
We do need a concrete core. So the cores of the 2 towers are made of concrete. Then the area in between the 2 towers is completely out of wood. So it's full timber. And then the floors of the towers, they are a combination. So that means the construction is made out of wood, but on top of that, we make a small layer of concrete, not for construction purposes, but just for acoustics. Because wood is such a light material, that's the advantage of wood for a lot of things, except for acoustics. So therefore, we make hybrid floors.
With its striking exterior, the multifunctional building complex will become the landmark of the new quarter, visible from almost any point in Eindhoven.
It's one of the highest buildings in the region. It's visible from a long distance. We wanted to make a very sculptural object also. 2 towers, one tower of 130 meter, the other one 100 meter. And instead of just making 2 single towers, we wanted to connect them architecturally, but also functionally. So that means that all the people who work and live in these towers, they also have a common place where they can meet and use shared facilities.
The new railway station will become the city's high-tech calling card, with a blend of living, working, and meeting zones. A city within the city will rise up here in the coming years.
Right now, it's still a little bit more expensive than building in a traditional way, but I think if the demand for building with natural materials will grow, also the business case becomes more and more interesting.
The Dutch mountains have long been more than just a vision on paper. They're going to become a reality. All it takes is a man who believes in it and doesn't give up.
This is a once-in-a-lifetime project. You can imagine as an architect, I mean, there are not so many buildings of this scale also, but also buildings which have so much ambition on different, on different fields. I mean, obviously it has a very architectural shape, a very iconic gesture. So yes, it's a very challenging project in many ways, and well, the scale, of course, is a once-in-a-lifetime project, absolutely.
The Dutch mountains will be the Netherlands' entry in the race for the tallest timber building in the world. Then, there will be nothing left to see of this parking lot. The race to build the tallest timber skyscraper has only just begun. Projects are being planned and prepared all over the world, so it's only a matter of time before these buildings are surpassed. But no matter how high the new timber skyscrapers become, people will remember what was once the world's tallest all-timber building in Brumunddal, Norway. Or the largest hybrid timber high-rise in the US in Milwaukee. And the next record breaker is already in the wings. In the Netherlands, the Dutch mountains will be the largest timber structure in the world. These are pioneering buildings, but they will not remain record holders for long. In any case, these buildings will always have one thing in common. They were the first of their kind.